So the way to think about it is, well, one, just let's do the easy ones. Let's figure out how many ways can I go from here to each intermediate cell, and maybe that'll help us to figure out how many ways can we get to this endpoint. So let me pick a suitable color. How many ways can I get from this starting point to this cell right there? Well, I can only go one way, right? I can only go from here straight to the right. So there's only one way. Let me write that right there. One way to get there. And how many ways can I get to this cell right here? There's only one way. I can only go straight down. Remember, I can't go to the right, down, and then the left, because left is not allowed. Every step has to give me some progress to my goal. So it looks like we've made a little bit of progress. So how many ways can I get to this cell? Let me write this. How many ways can I get to this cell right here? Well, I could go to the right here, and then I could go one more step to the right, and that's pretty much the only way I can get there, right? If I go down, I can't go back up. So there's only one way to go there. By the same logic, only one way to go there, just straight out. One way to go there, one way to go there. Similarly, these are you can kind of view these as symmetric. I mean, this is when you go straight to the right. This is if you go straight down. So this is one way, just straight all the way down. One way, one way, one way. Fair enough. Now, let's do a slightly more interesting cell. How many ways are there to get to this cell right here? How many ways? Well, this first time, let's draw it out. We could either go down and to the right, and we could go right and down. Right? So there's two ways to get to this cell. And that's fair enough. And this was easy to do, to work out all the ways, because there aren't that many. But you might already see an interesting pattern. If I have a cell here, let me draw a couple of cells. Let me draw 3 cells. No, that's not what I'm going to do. Let me draw it like that, and draw it like that. And, let's just say this is some arbitrary cell someplace in this grid. It doesn't even have to be a 6 by 6 grid. It could be an n by n grid. We could do this problem with 100 by 100, but then the video would take long to do all of the math. But let's say I wanted to figure out how many ways can I get to this cell right here. And let's say I know that there are n ways to get to this cell, and m ways, not m ways to get to that cell. So how many ways can I get there? Well, the only way to get to this cell, and I'll do it in another color, the only way to get to this cell, based on the rules I gave you, is either to go straight down or go straight to the right. So you can either go from this cell straight down, or you could go from this cell and straight to the left, or straight to the right. So how many total ways can you get to this cell? Well, the only ways you could have gotten to this cell is by going down from here. But there's n ways you could have gotten there, right? So there's n total ways that you could get to this cell and then go to this cell. And then there's m ways that you could get to this cell and then go to this cell, right? So this cell, or this box, I keep using the word cell, maybe because my brain is fixated on Excel. There are n plus m ways to get to it. And hopefully you understand that intuition, because there's 2 ways to get to this cell directly, from that one and from that one. And I'm saying that there's n ways to get there. So if all of the ways to get here, there's n ways to get here before that. And same logic for that. And you saw that right here. With the 2, it was 1 plus 1. So there's 2 ways to get there. And let's see if that logic holds one more time. Just because I don't want you to just take this as a leap of faith. It should make sense to you. So how many ways are to get here? So based on what I just told you, I should just be able to add 2 plus 1 and say 3. But let's see if that works out. So I could go all the way to the right. That's 1. I could go 2. Then I could go down that way, 3. And notice, out of all of the 3 ways to get here, 1 of them comes from this cell, and 2 of them comes from this cell. So that makes sense relative to the intuition I just gave you. So let's just fill out this box. Let's just fill out the box. This one's going to be 1 plus 2 is 3 as well. Let's fill out, let me switch colors just to make it interesting. This was 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And you can kind of see a symmetry along this diagonal. Right? There's a 3 and a 3, a 4 and a 4. And if you've seen the videos on the binomial coefficients or Pascal's triangle, you should hopefully start seeing a pattern or some recognizable numbers here. So what's this? This is 5. And this square has all sorts of neat things here, right? You have all 1s, and you have 1, 2, 3, 4, 5, 6. Well, 6, right? 1 plus 5. You see 4, 5, 6. 6 plus 4 is 10. 6 plus 4 is 10. 10 plus 5 is 15. 15 plus 6 is 21. 10 plus 10 is 20. 10 plus 5 is 15. 21. See, this is 35. 35. 70. 35 plus 21 is 56. 35 plus 21 is 56. 56 plus 70 is 126. 126. And then 126 plus 126 is 252. So let me do that in a special color. There's 200, right? 252 ways from getting from there to there.